All right, today we're tackling a big one, the immune system. We're going to break down the anatomy of a fight that's happening inside you right now.
So let me ask you this. How does your body fight a war every single day? I mean, really think about that. Right this second, you're in the middle of a silent, totally relentless war against trillions of invaders. It's a battle you'll never see, but it's one you literally can't live without. So how does this whole invisible army actually work? Well, let's dive in.
Okay, so first up, let's meet your immune system. And honestly, the best way to wrap your head around this whole thing is to picture it as a super organized military. I'm talking bases, command centers, boot camps, special forces, the whole shebang.
Yeah, your body's defense is basically a sophisticated army with a full-blown infrastructure. It's not just a random bunch of cells floating around. No, it's a coordinated system with actual physical locations. These are your lymphoid organs, and that's where the soldiers are made, where they're trained, and where they're deployed from.
Okay, let's break down that infrastructure. You've got your primary organs. Think of these as the training grounds. The bone marrow, that's your recruitment center, pumping out all the new soldiers. And the thymus, that's like the elite Special Forces Academy, where some very important cells, called T cells, go to mature. Then you've got the secondary organs, like your lymph nodes and spleen. These are the battle stations, the forward operating bases where the trained soldiers hang out, just waiting for the call to fight.
Now, this immune army is split into two main branches. On one hand, you've got innate immunity. These are your first responders, your frontline grunts. They are fast. They see something that doesn't belong, they attack. Super quick, but not very specific. They have no memory of the fight afterwards. Then you have the adaptive immunity. These guys are the special forces. They're slower to get going, but they are highly specific. They learn the enemy, create a custom plan, and this is the key part, they remember that enemy forever.
All right, so let's set the scene. An invader, say a bacteria, gets past your defenses. What happens right away? We're talking about the immediate response. The alarm bells go off, and the innate system's first responders are on the scene in minutes.
So who are these first responders? Well, first you have neutrophils. These are the infantry, the shock troops. They just swarm in and start eating invaders. Simple as that. Then there are the macrophages. Think of them as the guards. They also eat pathogens, but they're clever. They actually save little pieces of the enemy to show to the commanders later. And then you have the natural killer cells, or NK cells. These are the sentries, and their job is super interesting. They patrol for your own cells that have been compromised. See, when a cell gets infected by a virus, it sometimes tries to hide by taking down its ID badge. It's called an MHC1 receptor. NK cells are specifically trained to spot a cell that's missing its ID and just eliminate it.
But wait, how do these neutrophils even get to the fight? They're in the bloodstream, right? They don't just teleport. It's actually this incredible four-step process. First is margination, where they get the signal and start slowing down. Then they start rolling along the wall of the blood vessel, kind of tumbling end over end. Next, they grab on for dear life. That's tight adhesion. And then the coolest part, transmigration. They literally squeeze themselves through the wall of the blood vessel to get out into the tissue where the infection is. It's just wild.
So what's guiding them? How do they know where to go? Well, it's basically a chemical SOS signal. Your body releases these alarm molecules, things like complement C5a and cytokine IL-8, right at the site of the infection. It creates this chemical trail, like a scent for a bloodhound, that leads the first responders directly to the battlefield. It's a biological GPS. Okay, but what if the first responders are getting overwhelmed? What if the invasion is just too big? Well, that's when you call in the big guns. It's time for the targeted attack from the adaptive system's special forces.
So how does the message get from the front lines to the command center? That's where these incredible cells called antigen-presenting cells, or APCs, come in. Remember the macrophages, the guards that ate an invader and saved a piece? Well, they act like intelligence agents. They take that piece of the enemy, the antigen, and they travel to the nearest lymph node to present this intel to the special forces.
And who are they presenting this intel to? The T cells. Now, there are two main types you got to know. First, the helper T cells. These are the field commanders. As soon as they get the intel from the APC, they start directing the entire battle, releasing these chemical messengers called cytokines to rally the troops. And one of the troops they rally? The cytotoxic T cells. These are the elite assassins. Their mission is to hunt down and destroy any of your own cells that have been infected. They do it with a deadly 1-2 punch of chemicals called perforin and granzyme B.
But that's not all the helper T cells do. They also activate another critical unit, the B cells. And B cells are basically the Army's weapons factories.
Once the helper T cell gives them the green light, they transform into something called a plasma cell and just start mass producing millions and millions of these little protein weapons called antibodies.
And just like a real army, you don't just have one type of weapon. You've got a whole antibody arsenal. Take a look. You've got IgM, which is kind of the first antibody on the scene in a new fight. Then there's IgG. This is the main workhorse, the one that gives you long-term immunity. It's the most common one. IgA is like a specialized guard for your mucosal surfaces. Think your gut, your lungs. And then there's IgE. Its main job is to fight parasites, but it's also famously the one responsible for allergic reactions. We'll get back to that.
Okay, so the battle is won, the invader is gone. But it's not over. The aftermath of this war is just as important as the fight itself. We're talking about memory and misfires.
So the fight is over. The bad guys are gone. But how does your body make sure it remembers the enemy? Because this is where the real magic of the adaptive system comes in. It doesn't just win, it learns.
It's actually pretty brilliant. The adaptive system creates these memory cells. A few of those battle-hardened T cells and B cells stick around for years, sometimes for life. They're like veterans who remember the enemy perfectly. So if that same invader ever shows up again, bam, these memory cells launch a response that's so fast and so strong, flooding your system with IgG antibodies that you probably won't even know you were infected. That right there, that's active immunity, and it is the fundamental principle behind why vaccines work so well.
But what happens when this incredibly powerful system makes a mistake? A system this aggressive needs perfect control, because when it goes wrong, when it overreacts or attacks the wrong target, the results can be really, really bad.
So let's talk about when the system misfires. You've got hypersensitivities, what we call allergies. This is a case of mistaken identity. Your army sees something totally harmless, like pollen, but thinks it's a deadly parasite. So that Ig antibody we talked about goes into overdrive, causing a massive release of histamine and all those allergy symptoms. Then you have a totally different kind of problem, transplant rejection. And here's the thing, the army isn't making a mistake at all. It's actually doing its job too well. It sees a life-saving new organ, correctly identifies it as foreign, and launches a full-scale attack to destroy it.
And that really brings us to this final thought, which I think is so fascinating. Transplant rejection isn't a failure of the immune system. It's the immune system working perfectly, just against something we want to keep. It's a reminder that this whole system is this beautiful, complex, and sometimes kind of paradoxical machine. Its incredible power to protect us is always balanced on our knife's edge with its potential to harm us. It's a delicate dance between defense and self-destruction, and it's happening inside of you every single second of every day.